Now the keys have been acetone polished, which is why the ends are shiny, and you thread them through from the front, and then you need to put something in the back to stop them falling out. Now the previous design had tangs which sprang out on the back as you pop them through. The trouble is, when viewed from the rear, they looked a bit ugly. I mean, they work fine. So these are M3 by 6mm long bolts, and what you do is you put it through the key box here, and then you put the bolt in from the top. Now, do you have to put a nut on the end? No, you don't. The holes are just a tiny bit smaller than the thread of the bolt, so you don't even need to tap the thread. Just gently screw it in. Okay, here are the keys. See how they're numbered? Starting down here, 1 to 14, and then 15 to 24. These are the upper keys, these are the lower keys. The lower keys are upside down, they actually would go the other way up. See how the keys for the higher notes, see how they overlap somewhat? See how this tab overlaps the other key? You can see how I've filed it a little bit there, so it does actually move like that without interfering with the other key. So I'm going to start this end actually, so number 14 goes in there, and without any filing of the stem it should go in. It should be slightly loose. Operate the micro switch and spring back without any resistance at all. If there is any resistance, you can file the stems here, but you just need to do it very gradually and keep test fitting as you go. Especially these 5, make sure that they work independently of each other and they don't crash into each other. See, they're a peculiar shape to allow that to happen, which took a lot of work actually to get right. Now this one, you see how offset it is? Now the worry is that the key will twist and it just will look funny, which is why we have this little wooden rest here, and the same for this key. So you'll see that if I put it in, see how it rests on there? It doesn't fall over sideways. Just to see if that's true for the last one as well. Yeah. There, so a nice neat row of keys. I'm actually going to flip this over without letting them all fall out of the front. Okay, gradually. Take it easy, no rush. Flip it over. Now you see all these holes now I need to put these little bolts into. Okay, there we are. You'll see how 17, the corner of it rests on this ledge here, stops the key tilting. You'll see how these two bulkheads are between key stems, otherwise it wouldn't work. There we are, and now you see you can't actually see this plastic strip under there which holds these keys level. So again, carefully turning it around so they don't fall out. So the last two go in. Okay, check they'll work. Yep. Everything works. There we are. So it looks nice from the front, and it looks close, not exactly, but very close to the stem arrangement you'd see on a real hurdy-gurdy. This cover is held in with 3.5mm So that's M3.5 bolts. You don't need to tap a thread. The holes are just a tiny bit smaller than the bolts, so you just work them in. Again, don't over tighten it, otherwise you'll strip out the plywood. So that allows this to be removed should you wish to remove the computer and mail it to me. You may need to just file it a little around here so it clears the bezel of this button. These are just glued on. They're just labels for these 3 buttons, so your octave up and down moves everything up an octave or down an octave, all the strings. This one just moves the 2 of the strings up and down. I've actually countersunk these holes. I didn't use a normal countersink because it's so thin. I was worried it would just go through. So I actually used a drill bit, but spun it in reverse extremely slowly. That seemed to work. So these 2 parts of the 3D print project up by 3mm. So you see it exactly helps locate the top panel. And you've got these tiny little pilot holes here. Just show you where to start. And I'm using these tiny they're M2.5, it's 2.5mm diameter thread screws. There you go. Lovely and smooth. If you need to, just rub this edge here with the clear plain candle wax, and just on the inside of here, and the same the other side. If you find it's binding a little bit when it goes in here like that, see, and if you need to, just sand the edge slightly so it bevels in just a touch. I'm going to show you how to make the crank handle. Now you can just bolt a crank handle with these 2 holes to one of these flanges and that will work. This, you have to order the flange with a 6mm diameter hole in the center because they come with different size holes. I've taken the grub screws out because when you start cutting or doing anything to them, the vibration makes them undo, fall on the floor, and you never find them ever again. So the first one is to enlarge this hole. So we'll just drill out that hole. So what I do now is I put a bolt loosely just through this hole here, then I rotate this around until I find an area of metal under this hole, not a cutout, that I can drill and put a bolt through. And also I want this edge to again not be against a cutout because it looks nasty when I then trim it. So I'm against metal all the way around, so later on I'm going to trim this off around here. So I've drilled the second bolt hole there, then with a pen just mark this off here, and then we'll take this and saw it off in a curve and grind it smooth. So this one's ready to go. You can see it's bolted on. We've smoothed off the handle to match the flange, and don't forget to put the grub screws back in. Okay, this is how you solder up the motor. That's the negative, it's marked. That's the positive, it's actually marked under there. 4.7 ohms. This is actually 2.5 ohms, but 3.3 available, that'll do as well. Diode with the stripe facing the positive side, and then our orange wire, which will be positive to the analog input pin on the teensy, go to the junction between the two. Ground wire, white in this case, attached to the negative. To put the battery in, you undo the 2 screws here and then all gently pull it out, and we unscrew the tail. And then this part, it's not particularly well made, it's just a standard battery holder. This is the 18650 cell. You've got to buy the sort that's flat on both ends. if it's got a bump on the end like a normal kind of shape battery, which are available, it won't fit into this holder. The positive is the side with the grooved round it. You see there's a groove there. So now you insert this and then put the cap on the end. Now to charge this, you plug a micro USB lead from phone charger into the smaller top socket there. And in fact I'm just using one plugged into one of these USB charger sockets from my kitchen socket. So there it is plugged in. So if you want to run on internal power, let's say you've gone wireless, then you need to plug the USB lead into the internal power supply, which is the battery. So you plug it into the full size socket here. Right, you see how it lights up blue? And you'll see that the screen has now come on. It's booting up. And if you plug say a Yamaha or a WIDI Master MIDI Bluetooth transmitter into here, then it will compare with your laptop or your iPad, for example, wirelessly, and you can play wirelessly.